Hey guys, welcome back to another mini machine shop. I'm Dave. Don't really need to do an intro this time. Don't need a cheat sheet. All I have to say is I did receive a replacement die for the one I showed that broke, free of charge. Came pretty quick. The other thing is, one of the other videos I was showing making soft jaws. I completely forgot to add a little section of that, so that's the first thing you're going to see in this video. The rest of it's all self-explanatory. Alright, yeah, you can see that. I was just checking the run out on this, and I guess my vise had shifted a half a thousand. No, it was actually 1,000. This side was this way 1,000. So I had to re-square it up, so now it's zeroed, and you can see the needle on this. I'm checking the plastic soft jaws. And you can see it move about a half a thousandths down, so it's curved like this. And what I'm thinking happened is when I was milling this and drilling it, so it comes right back up to zero again. When I was milling it and drilling it, the heat warped it. And even though I've got this clamped in there, it should have squared it back up, but it's not. So I'm like from here to here, perfectly flat, and then both ends are out towards me a half a thou. So really interesting. Alright guys, the adapter came. The sleeve, I guess it's technically an adapter, MT3 to 2. That should go in there nicely. Yep, it does. Yeah, that's not coming out. Jeez. Same way with this. I got this stuck, and I had to put it in a vise and try to get it out, but there it is. Wow. That's pretty cool. Jeez, it doesn't look like there's any run out in it. Let me get a tool in here and let's see. I want this guy. Oh yeah, and watching the past videos, when I turn on this little light, it makes a bad glare, so you guys can't really see stuff. Alright, I'm just going to touch it because I wonder how much, it's probably going to touch it on the bevel part. No, I got to touch the whole thing. Let me do it with the boring tool. I don't want to mess up the outside of this. The finish looks kind of nice. Boring tool, where do we, there we are. I want this guy. Stick him in there, crank him down tight. Give it a slight angle, like that. Run it in there. Alright, let's see how out of round this thing is. Because it sure doesn't look like it's out of round at all. Yeah, I can hear it. I'm scraping it at, what is that? 30, 31, 32, 33. Take it down 1,000. Still scraping it. 2,000. 3,000. 4,000. 5,000. See if I can see it. Wow, it looks like it's cutting all the way around. So I don't know, I'd have to put a test indicator on here. Yeah, I'm going to put a test indicator on it, and I want to see just how out around this is. So, see if I can zoom in on that needle a bit, so maybe you can see it. Watch, I'm going to go the wrong way. No, I did the right way for a change. But here's the run out on this thing. And it is exactly 2,000ths. Slow it down a bit more. Yeah, because because I was manually rotating it, and I got exactly 2 thousandths, which is not bad, because what I did was raw material was clamped on this side. I drilled it all the way out. I tapped this. Then I spun this surface. Then I turned it around. I turned this surface. Then I turned it around in the 3-jaw, clamped this, and then turned that, and then started doing all the boring in it. So to wind up with 2 thousandths in a 3-jaw chuck, I think is pretty good. I'm not sure what the runout's going to... Well, the runout would be the same on the inside. So 2 thousandths, not bad. But doing it this way, when I put this MT2 in the tailstock, it should be right on the money and straight to do threading. Alright, just wanted to show it all. Just kind of an interesting note. The boring, the cutting itself actually sounds different in here. Something like it's more solid. It's kind of a kick. The surface looks really nice too. Actually, I should stop it and look at the surface. Look at that. That's different looking. It's got almost like it's got chatter going on. Doesn't look really smooth. I could probably change out. Yeah, I think I'll change out to a different boring bar, one of the better ones. Oh, that boring bar makes a big difference, let me tell you. Especially without cutting fluids, like, whoa, nice. Oh shoot, I'm using the wrong thing here. I'm using the compound and I shouldn't be, because I got the saddle strap in place. But in any case, that is nice. Well, there it is, guys. And I really had to whack on and wail on this stuff to get it out. But that's pretty cool. MT3, MT2. So, all I need to do is just drill and tap the holes on this guy. So, alright, cool. Yeah, well, I've got the camera zoomed in. On the last video I said I wanted to get to the bottom of why I can't tap or thread straight, and I think the problem is I'm finishing it by hand. Because if you'll see in here, I don't know if I can angle it, the threading doesn't really start until you're almost at the end or in the middle. It's tapered in here. And what I'm doing is I'm starting the threading using the machine, and then I'll pull it out and finish the threading by hand, and I think that's where it's going crooked. I can't keep it, perfectly straight. And by looking at the amount of taper that's in here, I probably just barely started the threading by the time I'm starting to poke out this end. So that's what's going wrong with that. So, and the reason I finish it by hand is because I don't want to put a lot of force on the machine here and on the tailstock. I just got to do it. On tapping, you can buy this guy, and it's just a spring-loaded, and it would be in the end mill, and you put it in the hole on the end of the taps, and it keeps it straight. And that way I can take this out of the chuck once I've got it started, and I can finish it by hand knowing that this is going to keep it straight. But all the small guys like this, they don't have the hole. It's just a point. So I made this little guy here. It took a day or so, 1018, and it's got a 90-degree in it. So that should hold it. And this was a pain to make because I had to get this. This was 1144 that I did the tip out of. And to get it right on the money, because I didn't want any play. There is like no play. I can't feel it move sideways. And this was also fun to make, and of course it's threaded crooked. Oh, this is threaded crooked because a die broke. So it's just a simple spring, built it around this spring and the sizing and stuff. And so that's pretty much all it is to it. That goes in there and that goes in there. Yeah, I'll show the die. This was a kick. Irwin. I'm still waiting to hear the final results from Irwin on why the die broke. They're telling me, oh, that's just normal use. Like, well, that was the first time I used that particular one. Where is it? Alright. Yeah, I'm threading away. It's going on this way. Next thing I know, the entire back pops out. All three sides, three pieces. Just mind-blowing. So they asked for pictures. I took all kinds of pictures of it and what I was threading and sent it to them. So let's see what they have to say about normal use and not a manufacturing defect. It was kind of a kick. I was just looking at this thing, thinking it was in here, and I had to put a screwdriver in there at an angle to be able to knock it out. And I'm looking at this going, there is a big dent in the end. I'm not sure if you guys can see that. Now this is supposed to be hardened steel, because I was originally just looking at it going, I don't see any marks on it where it was actually captured. Usually you'll see two spots someplace on it that from, and I put this in and out of a bunch of different things. So there should be some marks on it, but there's none, and I'm also knowing that this is really hardened steel. So I was surprised that a screwdriver put a big dent in it like that. I mean, a big chunk of metal here. And I went and looked at the screwdriver, and the screwdriver is fine. The ends of it doesn't. So my screwdriver is harder than this hardened steel? But Chinese are coming along. I mean, because whoever's doing this stuff now, a lot of the stuff that I'm receiving is just perfect. Just perfect. So I just wanted to show that. Kind of curious thing to discover. Yeah, this is the MT2 to MT3 adapter. And I was thinking, let me try drilling it out, because then I can probably put something through the hole in the back to tap and release things. So, here goes nothing. Let's see if we can drill it. Whoa, it's rocking. Can't hold it. Huh. How do you hold something like this with a taper on it? Look at that. Probably because I'm off center here. I don't know. Let's go slow. See if I can hold it manually. Yeah, it's drilling it. So hardened steel, it's not. There, it's more stable now. Oops, what did I hit? Something. It stopped going down. Why did it stop going down? Like I hit a stop. I don't have a stop in place. Oh, because it already had a pre-drilled hole, and I'm now drilling an entire hole. Yeah, get some oil down in there. Yep, there we go. Ooh-wee. That is crazy. So it's not that hard of steel, huh? It's not titanium. Going in. I could probably try another size up too, so I can get the biggest thing I can. This bit should be long enough. Wow. Deep hole. My hand's getting in the way. Come on, baby. Wow. I think it goes that far in. Oh. I'm pretty far down in there. It's hanging in there. I'll say that much for it. lucky is that, boys? For Christmas I got a whole set of punches. It just fits in there, and it just makes it. It's just long enough to knock it out. But watch, this will get jammed in there then. I can take pliers to this and twist it out, but so beautiful. Got that modified, and now I can tap things out easily.